All right. Hello, everyone. My name is Jesse, and I'm joined by my fellow team members, Kelly and Eric, who will have introduced themselves later into the presentation. And today we'll be providing an introduction to and overview of the Farm Robotics Academy. And to accomplish that task, we're going to set out to answer the following set of questions here. We'll cover what the Robotics Academy is, what makes it special, who all can participate, and what kind of timeline the program follows over the course of the year. We'll cover how teams and organizations can participate, about how much it costs to enter the academy and compete, and finally, we'll cover the prizes and awards that are available or up for grabs at the conclusion of the academy. We've also carved out some time at the end of the presentation for questions, so please feel free to post questions in the chat, and I'll pull them up at the end of the session for the group to discuss, and we can have a ongoing conversation about some of the topics that we covered today. So, what exactly is the Farm Robotics Academy? At its core, the Academy is a project-based agricultural technology program built around a real-world robotics competition. The Academy is open to students in grades 7 to 12, so middle school and high school age students. And additionally, the Academy offers professional development opportunities to educators in topics like robotics and agricultural technology that we'll discuss in a little bit more detail further into the presentation. So here's an overview of the program. Students come together and form a team, and that team can be based in a specific class at a high school or middle school. It can be a club or an after-school program, or it can even be programs like FFA or 4-H. This student team, under the guidance and supervision of a team advisor, which we'll define later, they go out into their community and connect with a farmer or grower or perhaps an agricultural business. And the team works with that. Let's stick with the farmer in this example. They work with that farmer to isolate a real problem or pain point that farmer is facing. And then over the course of the program, the team works towards designing and producing a solution to that problem. So what do we mean by on-farm problems or challenges? Kelly's going to touch on this in greater detail, but one element that makes the Academy special is that students can literally take on any challenge or any challenge faced by any farming activity. We've got some examples here. And as you can see, projects can tackle just about any challenge faced by farmers or growers. The crux of the challenge is addressing a real need in the actual communities in which the students live and learn. And to tackle that problem, another special feature of the Academy is that teams are absolutely open to and welcome to use any kind of technology, any type of tool or custom implement, a ground or air-based rover or drone, different types of applications for artificial intelligence, machine learning, you name it. This process occurs over the course of an academic year. So this process occurs over the course of an academic year where students are going to be developing, building, and then testing their solutions. And then the program concludes by teams submitting what we're calling a capstone project, which is a combination of a video report and a technical paper. Now, I know that that's quite a lot to take in. So we're going to drill down on specific elements of the academy and the challenge. And I'm going to pass over the presentation over to Kelly Scott, who is the director of the Farm Robotics Challenge and Academy. And he's going to take over and describe some of these elements that make the Academy special.
Fantastic. Yeah, thank you, Jesse, for that great introduction. So, as Jesse said, my name is Kelly Scott, director of the Farm Robotics Challenge. And our team here that you see, Jesse, Eric, and myself, all work for UC Ag and Natural Resources. And just wanted to spend a little bit of time explaining, if you're not familiar with UC A&R, who we are. So essentially, UC A&R is a division of the University of California that focuses on agriculture and natural resources. We have researchers throughout the entire state of California that work within communities. They're working on local issues and protecting the food supply and ensuring that our natural resources are safe. Um, when you think about UC, you often think of a campus like a UC Davis, a UCLA, UC Berkeley. We have affiliations at many of the campus sites, but we also have a footprint in California counties. So we typically say that our campus is the entire state of California, and we're really dedicated to preserving and advancing a safe and healthy, abundant food supply for the state. So this type of project really fits in our wheelhouse, where we have experts at every single level of agriculture, development, and production that are working under our umbrella. That also includes many statewide programs like 4-H, like the Master Gardener program, that are actively engaged in agricultural type activities. So that's a little bit about where we're nestled. This particular competition came out a few years ago, and we're started at the college level. And just this year, we introduced the academy as being the middle high school level. Jesse, you can advance the slide to the next one. And so as we're explaining this, I thought it would be helpful to give everybody a few minutes of highlight reel from what's happened at the college level in terms of the competition and project that Jesse just explained. This will give you some visuals, some real world examples of what teams have worked on as you start to think about how you might integrate this into your own programs and work on these projects. So this is just a short 2-minute video that gives some clips of the competition and projects last year. So you can roll that.
This year, the Farm Robotics Challenge brought together innovators from across the globe, uniting students, educators, and industry partners to tackle agriculture's toughest problems with cutting-edge technology. From reforestation to crop monitoring, from automating heavy lifting to protecting harvests, the 2025 participants have reimagined what's possible on the farm. Meet Johnny B. Root, a reforestation robot designed by Carnegie Mellon University. Johnny autonomously plants tree seedlings. With advanced navigation, AI-driven forest planning, and precision planting, Johnny helps restore ecosystems, sequester carbon, and bring new life to neglected lands. This technology not only tackles climate change, but makes reforestation accessible and efficient for more farmers than ever before. Warwick Harvest, a team from the University of Warwick, addressed critical issues faced by UK farmers, including labor shortages due to an aging workforce, decreased seasonal labor availability, and the high cost and environmental impact of traditional heavy machinery. The Warwick Harvest robot aims to protect an affordable, efficient, and environmentally conscious solution for spring onion harvesting. The University of Hawaii at Manoa Team Aina has developed an integrated system to address critical challenges in pineapple harvesting in Hawaii. The system's ability to combine automated bloom detection with 3D reconstruction offers a unique and potentially impactful solution for improving yield management, labor efficiency, and overall sustainability in tropical fruit agriculture. Hartnell College's Iron Claw Robotics team developed an autonomous artichoke crop monitoring system. Mounted with advanced cameras and integrated with machine learning software, their robot streamlines field inspections, improves yield predictions, and paves the way for smarter, data-driven farming. And at the University of Minnesota, the Farm Guard team created an autonomous drone system that detects and deters deer, protecting crops from wildlife damage. Their drone uses AI-powered vision, energy-efficient path planning, and reinforcement learning to adapt in real time, offering a cost-effective solution for small and mid-sized farms facing wildlife threats. This is a sampling of the 22 teams that competed in the challenge. These projects are more than technological achievements, they're a glimpse into the future of agriculture. By bringing robotics to the farm, the 2025 Farm Robotics Challenge participants are making agriculture more sustainable, efficient, and resilient. They're not just building robots, they're building solutions that will shape the future of food, the environment, and our communities.
So that's just a fun little clip to give you some ideas of what the college level teams are working on. Um, So, this year we have 63 uh, college teams at the Division One, four-year universities and colleges. Our Division Two, we have 10 participants, which are two-year community colleges, and then the academy is represents the middle and high school division that can compete in this competition to win prizes. But at this point in time, I think I'm going to hand it over to my colleague, Eric Dyer, who runs the Academy program, and he's going to give you all the good details on what it means to participate, um, compete in the challenge, and become part of this program. So, Eric, would love to have you take it away. And if you could give a little bit of information about your background, I think that would be really helpful for this discussion. So, over to you.
Thank you, Kelly. So, myself, I'm a veteran of the California Agriculture Teachers Network. I've been teaching in the public school for 39 years. I've taught floristry, ag mechanics, engineering, uh, many, basically all the topics at our high school. So, as I've started looking into this as a teacher, I started to say, hey, how can I bring technologies into my classroom? And an opportunity came up to participate in the Farm Robotics Challenge. And we started looking at how can we get it down into the high school level. So this is where we start, high school, middle school level. It's a 7th to 12th grade opportunity for an activity that replicates our 3 circles in the agriculture network of a project, a curriculum, and leadership. Um, As a teacher, I was always looking for an activity. So we're providing an opportunity for students, 7th to 12th grade. They do not necessarily need to be from a public institution. We are asking that they do have a certificated, vetted contact as the leader. By that, we all know if we're working with high school or middle school students, we need to have a Department of Justice backgrounds and fingerprints and all those fun things. And so that's one of the reasons we work with the 4-H and FFA advisors, because those programs are vetted. So we start working with the educators that way. And what do you need to know to participate? Nothing. We just know that one of the things that's coming up in our research is that the students in our communities think that the only place to work on technology and participate in technology is to go to the Silicon Valley. But the reality is, in every community in our state and nation, technology is now being used from what could be as simple as working on your own computer at home, bringing in the robotics that are coming in on tractors and other equipment that are in our packaging facilities and construction facilities. It's a significant issue, and we would like to provide an opportunity for our students to work in their hometowns studying and participating in the technology sector. All right, Miss. So what timeline do we follow? Well, typically we're going to follow the academic year. Start the activity in the fall. We're going to be doing teams register for the academies. We introduce it to the students. In my situation, I was working with 4 students at lunchtime. And as they started to get excited about it, they started to identify a problem. One of the problems that we were looking at was wireless fencing for livestock. So that was an opportunity to work because we had a local farmer, local rancher specifically, who was trying to develop local opportunity for wireless fencing. And so the students got excited about it and participated with it. And they wrote a proposal, the teacher wrote the proposal, and we submitted it. And that's how we started the program. So that's our step 1 in the fall. So you just gather the teams and introduce it. Then through the winter, what we did is the students worked together. We met. In our case, we were meeting at lunchtimes, but some of the students meet after school. Occasionally, we bring it into the classroom. And in that process, the students defined their proposal. And more importantly, they defined their responsibilities and roles and the overall project. One of the things that did happen is as the students started getting along, they started realizing that their capacity was not, they were not able to handle the task at hand. So they made some adjustments and reorganized and moved forward into a different topic. Still with livestock, they were very interested in livestock feeding, so that was where they went to. But they found that out because they had to start looking for materials and components, and they started to create prototypes. And as I started looking at these things, they said, "Woo, we're out of our league at this time." So they scaled back and came up with a new scenario. And then we jumped into the spring, and as the spring started moving forward, we started looking at how can we better the project we have. So we created prototypes, and we started evaluating could the prototypes handle the job that we were asking them to do. We're asking the teammates to resolve. And one of the things that we all also identified is our team needed to grow. And when we started with 4 students, we eventually wound up with 13 students on our team. One of the questions that's often asked is, how big can a team be? One of the schools interested in participating has 39 students in the whole school, 7th to 12th grade. And they would like every one of them to be involved. So my opinion is, bring it. Don't make it so big that it's unwieldy and not manageable for you as an advisor, but make it big enough so that everybody has a job. And some people will be involved with writing a report. Some people might be working on the finances. Some people might be working on the actual fabrication, and some people might be working on the actual technology. So it's a big deal. At the end, the students compile a summary of their research in the form of a science fair project. The agri-science project offered by California FFA and the National FFA is what our template is. And then they also produce a 5-minute video that captures their journey through the program. And those are submitted online in typically early May. And then at that point in time, the teams are judged by by a group of our industry partners and faculty and graduate students. And the winners are eventually presented in late May. That's our target. So we can stay within the calendar year. One of the unique opportunities we have is some of the students would like to participate and continue to work on their projects after they get feedback from the judges. So what we do, we have worked with the California Youth Agriculture Exposition, and we are going to help hold a second showcase event in the end of July, Tulare, California, and it will be a day that the students can actually present their findings to an audience and to the judges and to be awarded. Those students that are not winning that year, the teams that are not winning that year can continue to work on their project and keep moving forward with their team. So that's an exciting part of our summer. And then throughout the year, one of the uniquenesses, and I was one of the preliminary candidates for this. I don't know much. I did not know, I should say, I did not know much about robotics and drones. And so, through the academy, we are providing training for teachers and leaders in the areas of robotics and drones and videography and other technical topics that are necessary for people to participate with the competitions. For example, how to pitch, how to speak, do the public speaking component of it. how to organize your company and create an LLC even. And then who knows, we even have more as other topics start to arise. We can mobilize a team of industry professionals to support us in additional trainings. So the key is the first opportunity you can after August 1st is to register. Registration is at the Farm Robotics Academy.ai. Our website is open and has a nice opportunity and tab to say register here. Gather a team shortly thereafter of interested students. Key is a most important piece of this competition is to work with a local farmer, grower, or agriculturalist and identify a real on-farm problem. It does not necessarily need to be in the area of crops. It could be animal projects. It could be urban forestry. It could be riparian studies or working on the coastline. Um, any area of agriculture that's recognized, horticulture, in a greenhouse, outside the greenhouse, landscape purposes. So the solutions are very broad based. The topics are exceptionally broad because when we think about it, just in California, going from Potter Valley up in the Klamath River, you're looking at the destruction of the dams on the Klamath River, all the way down to the greenhouses of the Carlsbad region of California and San Diego. So we have a very large spectrum of competitors and topics, and it's based upon your local needs. And then as you do your work, research it, we develop the prototypes, test them, and then deliver the project in early May. So one of the questions as a teacher I would always want to concern myself with, and one of the things that's important at this time of the year for schools is to start their budgeting process for next year. Typically, our best estimates are going to be your team could spend $5,000 to $10,000 on a project of this size. That should include the substitute days, travel, tools and supplies, any machining or fabrication that needs to be done. If we need to buy equipment like a drone or a rover or other, maybe a computer, maybe you need to buy video equipment or software. Some of these things start adding up. Right now we are going to start charging a $100 fee to participate. But the bottom line is we need to start um, budgeting now for this next year as we start developing our projects. So a good question to always ask is what kind of awards or prizes are going to be available? These are some of the awards that we are currently offering this year for innovation, the specialty crops, drone applications, artificial intelligence, and regenerative agriculture. And we're still working on additional prizes. That's why we have an in progress background up here. This is a program that is continuing to grow. Currently, the grand prize of the whole system from seventh grade to postgraduate is a $50,000 award for commercialization. And the key component is that the winning high school student moves up to compete against the junior colleges. And the winner of the community college Division II gets to move up to compete against the four-year Division I teams. This is a little program that started locally and has grown to be an international competition. It's very exciting. The National 4-H and the National FFA are both participating in some way at this time. So we're trying to grow the program across the nation at this time. So this is our opportunity for awards. Okay, in saying all of that, which has been a brief description of all the activity, this is our contact information. Are there particular questions that we can answer now? We're very encouraged to have everybody participating today. Also, we're going to direct you to our webpage, farmroboticsacademy.ai, for further information, as that's even more developed in this presentation today.
Thanks so much, Eric. I'm going to open it up so that participants can unmute themselves and jump in and say hi or ask a question if they'd like. So please feel free to either unmute or use the chat feature to submit any questions that you have.